As we continue to work with functions, it's important to understand what the notation is telling us about a certain situation. And in order to do this well, the most important thing to recognize is what are we inputting and what are we outputting, and how are we to understand the units of that input and output. So let's look at an example. We're going to let the function d of t give the number of ducks on a pond t hours after 3 p.m. So in this case, we're inputting t and we're outputting some d of t. So we're inputting t and we're outputting d of t. And it tells us t is hours after 3 p.m. So when we see something in place of t, this is hours after 3 p.m. d of t is the number of ducks. So our units of t is specifically hours after 3 p.m. In our output, d of t is number of ducks. So if I wanted to explain the meaning of d of 4 equals 338, I want to recognize that my input is 4 and my output is 338. So as long as we understand what the units of those are, we should be able to make a good interpretation. So 4 is 4 hours after 3 p.m. and 338 is my number of ducks. So there's a couple ways that we could write that out. So the first way is that 4 hours after 3 p.m. there will be 338 ducks. I could also say we know that 4 hours after 3 p.m. is equivalent to 7 p.m. So I could say perhaps there will be 338 ducks at 7 p.m. Or I could say at 7 p.m. there are 338 ducks. As long as we understand what the 4 is and what the 338 is, there's multiple ways we could state this in practical real-world terms. Well, how about this now? Explain the practical meaning of d of negative 1 is 245. Our input is now negative 1, and our output is 245. Negative 1 means 1 hour before 3 p.m. So in this case, 1 hour before 3 p.m. is 2 p.m. So an interpretation could be that at 2 p.m. there will be 245 ducks. Sometimes we don't fully know what the input variable is or the output variable is, so we represent them with a variable in itself. We replace it with something. So here I'm inputting, instead of t, a, because perhaps I don't know what t is specifically, but the output is still 300. As long as I recognize that a is in place of t, which is hours after 3 p.m., then this is telling me a hours after 3 p.m. there will be 300 ducks on the pond. And so a could represent a variety of things in this context, but it's essentially just all of the time values where there are 300 ducks on the pond. Keeping that same scenario, just two other circumstances. Explain the practical meaning of f of 2 equals b. So let's cross that out. Let's make that d of 2 equals b so that we're keeping the same notation. Our input here is 2. Our output is an unknown, it's B. We still recognize that 2 is our input, that's 2 hours after 3 p.m. there will be B total ducks. Or I could say at 5 p.m. there will be B total ducks. Lastly, explain D equals D of T. We've simply just reversed the order of the output. Now the output's coming first, uppercase D. The input is still T. So the input here is still T. And now we have an output, which is also represented by a variable. This is uppercase D. So this is simply telling us T hours after 3 p.m. there will be D ducks, uppercase D ducks on the pond.